This is a similar but different question based on Pure Book 1, Exercise 6M, Question 7. So we're told that we have a line which does not intersect a circle with a given equation, but we're not told the coefficient of the x in that equation. And we need to discover what the possible values for p will be. So the first thing to do is to rewrite the line equation in this form, because we're going to substitute it in to the circle equation so that we can actually work out where they cross. So remember, where they intersect, the x of the line and the circle must be the same, and the y of the line and the circle must be the same. To make things a bit easier for myself, I factorized that part of the circle equation. So that means that I won't be having to multiply and then add more on. I'm just going to use GeoGebra to model it for myself. I put in the line there and the circle there. I've also marked where the center of the circle is. I've used a slider to control P. Remember, that's the coefficient of x in the circle equation. So as we slide that along, changing the coefficient, see what happens there. So essentially what's happening is the center is moving out one way or the other way. And at that point, we have two intersections. Still two intersections. And just about there, so around 10 or 11, we get to the point where the circle is just touching the line. And now, of course, it's no intersections until we get to just about there. So around 67, 70, something in that region is when it starts to intersect with that line again. So now I've substituted for y in the circle equation, and from the interactive, we're expecting to see that p can be between 10 and 70 approximately, and those will give us solutions. And if we go outside of that area, then there won't be any solutions to this quadratic. So I've simplified the quadratic, and now I'll use the discriminant to find possible values for p, which will give me solutions. So I now tell the examiner my reasoning, and I state what the formula for the discriminant is, and also what I actually want to be true about it and why. I'm looking for the interval where the discriminant is less than 0. So I'm going to look for the two roots, and then I'll work out what the interval is from there. And that means I need to use equals here, because I'm looking for where this intersects with its x-axis. Remember, this graph is distinct from the circle with the line on it graph. So this is a positive x squared graph, and so that means that it's going to be under the x-axis there. So it's this interval between the two roots that we want. So we want p to be between the two roots. And remember, we want them to be no intersections at all. So these have to be strict inequalities.